With this video, we will have completed presentations covering the design and operation of Texas's 14-inch guns and turrets. Before starting, I want to recognize Christopher C. Wright of Warship International, who wrote the paper Main Battery Guns of Battleship Texas BB-35. Little of the following would have been possible without the treasure trove of information contained within it.
The original guns that were mounted on Texas in 1914 were Mark I barrels. This was the very first and original design. Now those barrels were replaced in 1923 because they had been fired enough to have been considered inaccurate. So they were replaced, and they actually took on barrels that had been relined or rebuilt. Those stayed on board until 1935, when once again they were considered worn enough to need replacement. And then so they were replaced yet again. And then finally, there was one last barrel change that lasted from September to October 1944, after D-Day and after Normandy, and those are what stayed on board for the remainder of the ship's career. And these are these barrels. These are the same barrels that were installed in 1944. Now, there's something really special about it, because the barrels that were originally on board, that were unlined, that were brand new, fresh barrels, guess what? These are them. Those same barrels, even though they were rebuilt twice and ended up serving a lot of their lives on Battleship Pennsylvania, came back home to this ship. So we're actually looking at barrel number 2, barrel number 3, barrel number 4, barrel number 5. Those are the actual serial numbers for those barrels. The only thing is there's only 9 of those original barrels. There's one that was used to replace the 10th original one that's back on turret 4. But it was tracked down, the original barrel, and it was found at the Dahlgren Proving Grounds in damaged condition. So all of those barrels that you see here are the original barrels that were installed on Texas in 1914. But they're not really the same, because every time a barrel went back in for rebuild, they took every opportunity to upgrade them and to improve them. And there's a huge difference between the way they were in 1914 and the way they ended up in 1944. One of the things was the liners were plated with chrome, the bore was, and with that, it increased the service life of the barrels from 150 to 250 rounds. We're going to get into that in a different video, though, because there's something that's really kind of misleading about that. But anyway, nice history, nice trivia.
As you can see by looking at a breech stamp typical of all of those on Texas's 14-inch gun barrels, it and the others were built in 1912, and all were installed on the ship over a 6-month period in 1913. Here's a list of serial numbers for the guns and the factory where each was produced. As you can see, the great majority were fabricated at the Navy's gun factory in Washington, D.C. The 1914 guns were a Mark I design, making them the first in a succession of 14-inch designs and modifications. Like most new barrels, they were not sleeved but had a thick gun tube that was rifled. Their thickness made it possible to rebuild and reuse barrels many times by boring the tubes to enlarge them and installing removable rifled liners. The engravings and stamps on a barrel's breech tell a lot about each gun and its history. The top engraving shows that this barrel was built at the U.S. Naval Gun Factory at the Washington Naval Yard in Washington, D.C. Below that, we can see that this is a Mark I 14-inch gun with no modifications. To the right is this gun's serial number, which is 12. The barrel's weight, including the breech mechanism, is 137,800 pounds. Beneath that is the gun's year of manufacture, which is 1912. As we progress, we see the factory superintendent and the production inspector's initials. Finally, there are the initials of the inspector who proofed the barrel when it was test-fired a number of times at the Navy's proving grounds. An L was stamped behind the serial number the first time it was relined. Also added were the rebuild year and new inspector and proofer's initials. Rebuilt barrels typically included design changes, so the old mark and mod designations were ground off and new ones applied. If relined a second time, a number 2 was stamped behind the L, mark and mod numbers were changed, and new dates and inspector's initials were added. So serial numbers always reflected the number of times barrels had been relined and rebuilt, along with the additional years and inspectors. With this, we can clearly see that barrels now in Texas were relined twice, except for the odd barrel 8L3 that was rebuilt and relined 3 times. With the serial number information provided by Mr. Wright, it was an easy matter to locate each barrel's current location by using breech photos taken when the turrets were photo archived. It's a shame that we don't know their original 1914 installed locations, because it would have been fun to see if any found their way back to their original turrets when they returned in 1944.
So all 10 of the barrels that you see here, as I had said before, were replacements installed on board between September and October of 1944, just prior to going to the South Pacific and where they saw action at Iwo Jima and Okinawa. Now, during that action, they were fired a total of 2,942 times. If you break that down and just average it out, 294 times per barrel, which exceeds the barrel's 250 round life. But does it really? Well, let's make it a little bit worse, because before the barrels were even installed on the ship, each one was fired a few times at a proving ground to make sure that they were going to work properly. Then they were also used during target practice before reaching the South Pacific. So they actually have more than 294 rounds per gun tube or per barrel. But surprisingly, they really weren't that worn. That's what we're about to get into.
The ship's 1914 barrels had a life of only 150 shots, but they had a life of 250 shots when they ultimately returned to the ship in 1944. This was made possible by chrome plating the barrel's bore and rifled surfaces as part of the Mark 12 design. Even with that improvement, how can a barrel's life be stretched to more than 3,500 shots? We need to start by looking at the kinetic energy contained within a shell as it moves. This is determined by two things: the shell's weight and its velocity. Here's the formula, but don't bother trying to learn it. There won't be a test. All that's important to see is how changes in weight and velocity affect a shell's energy. Let's ignore the 0.5 multiplier for a moment. Changing a shell's weight is very straightforward because it affects its kinetic energy content in a direct one-to-one manner. In its extreme, double the weight and you double the energy. However, velocity is a different animal. A shell's energy content squares with changes in its velocity. Looking at a graph makes things a little easier. The blue weight line shows that any weight increase changes the energy in a one-to-one fashion. Now take a look at the red velocity line. Not only does energy increase at a faster rate, look at the vertical scale. Instead of 1-to-1, it's 1,000 to 1. So even a small change in velocity has a big effect on a moving shell's energy content. So what does this have to do with barrel life? Absolutely everything. If a shell contains 10 times more energy due to increased velocity, that energy must be produced using enough additional powder charge to generate the required increase in gas expansion and temperatures. These superheated gases and extreme pressures instantly heat the bore and rifling surfaces by thousands of degrees, creating tiny cracks and checkering on them. They also create microscopic flakes and particles that blow off with each shot, thus causing bore erosion. Chemical interactions between the gases and steel can also add to the problem. As the powder ignites, the gases it generates pass through the constriction of the compression slope at the front of the powder chamber and funnel into the bore of the barrel. This not only increases gas velocity to improve shell acceleration, it also concentrates erosion at the slope and at the beginning of the rifling. With each shot, the erosion worsens and progresses down the barrel. This causes the shell's velocity to gradually slow over a series of shots because gases escape past the shell between its driving band and the eroding bore. There's another problem with worn barrels. The shell's borelette is its forward bearing surface that rides on the rifling. As it moves through the bore, the rifling's worn and increasing diameter allows the shell to slightly wobble in the barrel with a circular motion as it spins. That wobble will carry over to its flight after it leaves the gun. The result is inaccuracy that slowly builds as the bore wears until it reaches unacceptable levels. It's that point that determines the barrel's life. While we still haven't answered the question of how we get more than 3,500 shots out of a 250-shot barrel, we now have the tools needed to understand it. At 1,500 pounds, the armor-piercing shell is the heaviest type fired in the 14-inch gun. It also requires the largest possible powder charge to accelerate it and achieve maximum penetrating performance. This combination of heaviest shell weight and maximum powder charge creates the greatest bore erosion, so it's used as the standard means of determining a barrel's life. The wear created by firing one of these shots is called an effective service round, meaning that every time an AP round is fired with a full powder charge, the barrel is worn by a factor of 1 ESR. That means that the barrels now in Texas would have far exceeded their lives of 250 rounds if the average of 294 per gun fired at Iwo Jima and Okinawa had all been full-charge armor-piercing. Fortunately, things were much better than that. If we change to the lighter 1,250-pound high-capacity round, something good happens. It takes less effort to accelerate the shell faster, so it leaves the barrel sooner. This results in lower pressure and temperature, even when using the maximum powder charge. Therefore, the effect on bore and rifling is less, and erosion is reduced to 78% of that created by the full-charge AP shell. This creates an ESR of 0.78 every time one of these was fired. Because of that, firing only high-capacity full-charge rounds would result in a barrel life that increases from 250 to 320 shots. Even though the Navy's regunning policy would have required a barrel change before then, they still would have been within acceptable tolerances. We now come to the ultimate way to improve bore life. Because AP shells typically used a maximum charge to achieve best performance, little could be done to save barrels if that was the only thing fired through them. However, high-capacity shells only required reaching the target with enough force to cause them to explode. This allowed the use of a reduced powder charge to propel them when targets were well within maximum range that resulted in extreme improvement in the life of gun barrels. The result is bore erosion drops to an amazing 0.07 ESR, which would allow about 14 rounds of reduced charge high capacity to be fired for every full charge armor-piercing round. This is what happened when Texas fired a total of 2,942 high-capacity rounds at Iwo Jima and Okinawa. Documents state that at least 1,894 of those used reduced charges, which greatly extended the barrels' lives. That means that they could have fired an additional 173 armor-piercing rounds from each barrel for a total of 1,730 AP rounds for all 10 guns. Even more incredibly, each barrel could have instead fired an additional 2,471 reduced charge high-capacity rounds. That is an amazing total of 24,710 high-capacity reduced charge rounds for all 10 guns before they would have been too worn for practical use. To do that would have meant emptying and reloading the ship's magazines 25 times. With that, we can see that the barrels now in the ship still had plenty of life left in them. In fact, there would have been more than enough for her to continue the fight as part of the invasion of Japan had it been necessary.